Hello, Fruitport High School AP Chemistry class. Here's our lesson for today. We're going to try to review the mole and the mole roadmap and conversions. It's a review from chemistry, but it's not always everyone's favorite part of chemistry. The other thing is that I'm going to try it like a flipped classroom. So we haven't covered this in class. We're going to do this now, and then next class, we'll go over all the questions you have, dig a little bit deeper, and so on. So hopefully you picked up a mole roadmap the day before, and I'm going to try to do things all on the screen pointing down. So you'll hear my voice, and but you'll see the paper as I write things down. So let me move the camera around and set it up like this. And maybe I can zoom in for us to get a decent lesson. All right, so the mole. So if you remember that we have a lot of fun with the mole in chemistry, and we because maybe it's kind of boring to learn, but the mole is a unit that we use for counting. Remember, in this class, we count very, very small things, and so even a small speck of a powder just has billions and trillions of little tiny particles in them. And so we use this number to represent a mole. It's 6.022 times 10 to the 23rd power. We call this Avogadro's number. The symbol is numero de Avogadro, so it looks like this. And you'll see in our mole roadmap sometimes us type the number out, or sometimes write this symbol out here instead. And this is something that we'll have to make sure we can plug into the calculator. I suggest using the EE button as we reviewed, otherwise you'll need some parentheses around it. Okay. Now the key part of the mole is that it ties everything together. Here's a good chemistry mole roadmap, and you'll see a bunch of different samples all tie to the mole. And in fact, today, I'd like you to add a couple other steps. So we have a number of particles. A representative particle could be an atom or an ion or a molecule or a formula unit. We have mass in grams, which is very key because that's how we count in this class, by weighing things first. And then we have this useless area, volume of a gas in liters, but we can also go back and forth to volume of a gas if we are not at STP, and we would use this formula, which we'll have to review at some point. PV equals nRT is a way. The N stands for moles. And today I also want you to practice, add this one, liters of solution. And a liter of solution is talking about a concentration. So yeah, so this would be a mixture like of salt water, or 6 molar hydrochloric acid or something to that effect. And we're going to add some arrows to help us out with this. Now, I don't really use the mole roadmap once I get past the beginners because I use dimensional analysis, but I know that this first time back, we like to use this. Okay, so this road of the map here, between moles and number of particles, we use Avogadro's number to count these. So if you had a practice problem where we wanted to convert between number of particles in the moles, we would do this. And we always start with this, but it's not maybe the best policy because we have it's not a very used form, for instance. So let's say we knew that something was exactly 0.34 moles, and let's give it a compound. Let's say of carbon dioxide. And the question was, well, how many carbon dioxide molecules are there? And remember that mole is not short for molecules. Moles is its own separate thing. That sometimes comes up. And so I'll use the red marker to write the problem out, and I'll use a different marker to solve it. So according to the mole roadmap, I have a unit that is moles, so I'm going to start there. That's my green start sign. And I want to stop here. There's my red marker. And it says to go from the green to the red, I want to take the moles and multiply by Avogadro's number. And so I would take 0.34 and I'd multiply by 6.022 times 10 to the 23rd, and I will get an answer. Now, I'm going to do this on my calculator screen. Maybe you can see it on the audio, but 0.34 times, and then I'll hit 6.022 E23. And I get an answer that has a little bit more on the screen than you might notice right away. We got this 2, but don't forget this E23 at the end. So if I move it over to write down my final answer, I'll have 2.04748. I don't know. If we start with a couple significant digits, I should probably end with a couple significant digits. So since I started with 2 sig figs, I'll end with 2 sig figs and say 10 to the 23rd carbon dioxide molecules. Okay, now a couple advanced things here because I don't want to take up too much time. What if they didn't ask us how many molecules, but asked us how many atoms? Carbon dioxide is not an atom alone. It's 3 atoms all linked together. So we would then take this number and triple it because we already have how many molecules. And if I wanted how many total atoms, I could take my number of molecules and multiply by 3. Now, if I was given a different substance like sugar, which has a lot more than 3 molecules, a lot more than 3 atoms in the molecule, I would use a number that was bigger than that, of course. Okay. The other warning is that because I did a multiply as an example, please excuse my dear Aunt Sally and my calculator are working fine. But you should practice in the homework if you have to go in this direction. We'll do one of those later. Because if you don't use parentheses or you don't use the double E button and you use divide, please excuse my dear Aunt Sally, could get a little bit screwed up. Okay. All right, the most common thing that we should review on today's lesson is this, the molar mass and how to convert between moles and grams. And so for our second sample problem, I want to go over what is molar mass. So I'll flip this sheet over and sample problem number 2, right? We need to find molar mass hundreds and hundreds of times in this course, and so we should make sure we can do this, right? So find, or maybe calculate, the molar mass of, and let's do something that has some parentheses to make it a little bit more challenging. So this is copper Roman numeral 2 nitrate, and that's a Cu parentheses NO3 parentheses 2. So to find the molar mass of this, we are going to need a periodic table. And in this periodic table, I'm going to need the mass of copper and the mass of nitrogen and the mass of oxygen, because those are the compounds. And we're going to have to add up the atomic masses of these materials, because those are also the molar masses of those materials. And so to do this here, the solution is I need to add up the weight of a copper plus I need to add up the weight of 2 nitrogens. This 2, remember, distributes. There's actually 2 separate nitrates. So you can do N times 2 or N plus N 2 times. And then I need 6 oxygens. And maybe I'll just do oxygen and I'll kind of put a times 6 because I'm going to need 6 of those. You guys know I could add it 6 times or multiply, I get the same answer. So if I look up copper's mass, I get 63.5. Nitrogen is around 14, and I can double it or add 14 again. And then if I look up oxygen, oxygen weighs 16, but I need 6 of them. And so in my calculator, I will take 63.5 plus 14 plus 14 plus, so maybe I'll do 16 times 6 because I don't want to have to punch it in all that times. And I get 187.5. Now, if you're really into watching units, that's how many grams are needed to make a mole. And molar mass is different because we're counting things, not counting how much they weigh. Just like 12 donuts will not weigh the same as 12 peanuts. But they both have 12, but their individual components have this. So this is the molar mass. Why did we find the molar mass? Well, if we ever want to convert between grams and moles, we'll either divide by molar mass if we're changing grams into moles, or we'll multiply by the molar mass of the substance if we're going moles into grams. So let's continue with the same chemical since we have it to make the video efficient here. All right. So let's say that this is like maybe 2A. Let's say we have part 2B. And the question was, well, how many moles are in 100.0 grams of copper 2 nitrate? And I put in the 100.0 just so we have 4 significant figures to kind of guide this. Okay, so if we take a look at the mole roadmap, I think that we're given a grams. That would be our starting point. They asked for how many moles. This would be our ending point. And so the mathematical function is to take grams and divide by molar mass. So my answer will be oops, you can't see that. I'm going to slide this up. 100.0 grams and divide it by the molar mass, which we just found out was 187.5 grams per mole. And I'll punch that in my calculator. I got 100 divided by 187.5, and I get this complicated answer there, 0.53333 repeating. And so, because we've learned significant digits recently, I think I'm going to go ahead and follow the rules. And I'll have 1, 2, 3, 4. That is how many moles of copper nitrate we have. That has 4 significant digits. Okay. Now, we could have 2 steps in one problem. So let's continue on. So in our third question, our third sample question, let's say that we were given, I don't know, 50 million platinum atoms. And we wondered how many grams of platinum. Like, is that heavy if I gave you 50 million platinum atoms? And so we're going to jump right to the mole roadmap here. Atoms is a type of particle. We have a number of particles, so we'll start here. And they ask for grams, which is a mass, which is over here. So my two-step approach for this question, well, let's see, I'll do that orange. We're going to take atoms and turn that into moles. Then we'll take the moles and turn that into grams. To turn atoms into moles, it says we're going to divide by Avogadro's number. And to turn moles into grams, we're going to multiply. I'll do it mm for molar mass. That's not millimeter or something else. That could be different. Okay. So you can do this in 2 steps on your calculator or 1 step. I like to do it in 1 giant step. So I'll take my 50 million atoms, and I'm going to divide by 6.022 times 10 to the 23rd power, and that will equal moles. And I guess I'll do it 1 step at a time just to show this here, but 50, 1, 2, 3, 4, 5, 6, that's 50 million divided by, I'm going to use parentheses. No, I don't need parentheses, 6.022 because I'm going to use the E button. Whoa. I only hit 1, 2. E23. And I get 8.3. And careful, there's this times 10 to the negative 17. That's really important. Moles of platinum. And then for step 2, I'll take that moles. 8.3 times 10 to the negative 17 moles of platinum. And I'm going to now multiply by the molar mass. But I don't have the molar mass memorized, so I have to look it up. This time I don't have to add it up because platinum's pretty basic. Platinum is way over here. Looks like it's a 195.08. I'll use 195. If you want me to show you dimension analysis, remember the units are grams per mole. And these moles would cancel out. So I'll take my previous answer, multiply by 195, and I get an answer of 1.6 And I guess it's kind of hard to watch sig figs. Maybe this has 4 sig figs, so I could use that in my final answer. 9 times 10 to the negative 14 grams of platinum. Okay, so punching this in your calculator has its problems, and following the steps, try not to make a mistake along the way. I'm hoping some of this is coming back to you. Now, the new part of our notes is going to talk about concentration, solution, okay? And there's a new concept I want to use called molarity that will help us connect moles to liters. So what is molarity? Molarity has a giant M for its symbol, and it's a unit of concentration that measures how many moles are dissolved in the liter of solution. All right, so the units are moles per liter. So watch this. If I take liters and I multiply by moles per liter, the liters will cancel and I'll just have moles. Okay, and so we can add this. Liters, moles per liter is molarity. So let's go back to this. And if I want to turn liters into moles, I will multiply by molarity. And then if I want to do the opposite, if I have moles and want to come into liters, we'll divide by molarity because it's the opposite. Notice that some students in the 10th grade say, oh, this arrow points to moles as divide. I'm not even going to practice this one because it's so useless. That's divide, and this one's divide. Notice this arrow that points to moles is not a divide. That one is actually a multiply. Okay. So we can now use this for one last practice problem today. So let's do number 4, our fourth and final practice problem, right? Let's say we took 5 grams of NaCl and we mixed it with 100 milliliters of water. The question is, what is the molarity? Now this one's a little bit trickier it's not quite on the mole roadmap, but you'll see what I'm getting at here, okay? So I have grams, but I also have liters. I gave you milliliters. Which one do we start with? Well, we're gonna need both. And they're asking us what's the molarity, which is a conversion factor. But we know molarity is moles divided by liters. So if we find moles and we find liters, we can find molarity, okay? So, so the first thing is to take this 5 grams and change it to moles. And 5 grams, if I were to multiply, well, I guess I'll say divide just to keep it up here. If I divide by the molar mass, which sodium weighs 23 and chlorine weighs 35.5, if I want to add that together, 23 plus 35.5, that's 58.5. I'll put in 58.5 here. 5 divided by 58.5 equals this number. Oh no, I lost it. It equals 0.08547 moles. Good. And then the molarity, the second phase, maybe I'll do a second green marker here. Molarity equals moles divided by liters. And we know the molarity is 0.08547. And then we can practice the metric system. Milliliters to liters is 3 steps, so 0.1 liters. And I can just divide by 1. Maybe you can do that in your head. And this would be the molarity of the salt water solution that we made. Okay. All right, so that was that wasn't short. I know that's a lot. I'll share some other videos, and you guys can attack the homework, and we'll answer questions when I see you next. Okay, good luck, everybody. Check Google Classroom for more details.